Okay, so it is time. I think I should start now. Yeah. Okay. So good afternoon, everybody. I am Sapanjana. I am a PhD student in the mathematics department. I am also a PMRF scholar and an integral part of the NPTEL course NOC23-ma27. The name of the course is Integral and Vector Calculus. So today is week 10 discussion session, live discussion session. So today we shall see some applications of volume integral, in particular Dirichlet formula, Liouville extension formula of the Dirichlet formula, and in the last half we shall see surface integral and see some applications of surface integral. So we'll do some problems. In fact, I shall prove how the surface integral is defined in such a way. Anyway, so let's start from the beginning and share my screen. Yeah, I hope my screen is visible to all of you. So let's start. Yeah, so today's basically topic is Dirichlet theorem, Liouville extension theorem of the Dirichlet theorem, surface integral and Gauss Divergence Theorem. Okay, so we shall start from Dirichlet theorem. So the statement of the theorem, you have seen volume integral, so there should have no issue. So the theorem says that n many integrations are there. So x1 power l1 minus 1, x2 power l2 minus 1 dot xn power ln minus 1 dx1 dx2 dxn is actually equals to gamma of l1 times gamma of l2 times gamma ln divided by gamma of 1 plus l1 l2 ln, where all li's are positive numbers. So yeah, so that is not written, where the integral is extended to all positive values of the variables, that is x1 x2 xn's are all positive and they satisfies this condition, right? And I should also write the what is li's. And okay, li's are positive. Okay. Positive numbers, positive real numbers. Okay, now I think it is fine. Yeah, so let me do one thing, otherwise it will slow down. Yeah, I am turning on my videos because then the screen will be more faster so that you can follow more. So let us start the proof, right? So here the theorem is stated although in n variables, and you are familiar with three variables. So I shall do the proof only for three variables. So I shall not go beyond three. Yeah. So for n equals to 3, right? So given triple integration, we can write given triple integration can be written as integration, since all are positive and their sum is less than or equals to, so this is, so I shall now use, since we are in three variables, so I shall use x, y, z coordinate, and z equals to 1 minus x minus y, x to the power L1 minus 1, y to the power L2 minus 1, z to the power L3 minus 1, dx, dy, dz. And this is actually equals to 0 to 1, x equals to, y equals to 0 to 1 minus x. We can write this as x1 whole power L1 minus 1, y power L2 minus 1, and if you integrate and put the values, then you will get 1 minus x minus 1 whole power L3 by L3 dx dy, right? Now this is actually equals to 1 by L3 take common and put, okay, so let yeah, so put y equals to 1 minus x times t. See, because y is also running from 0 to 1, so if you multiply it by t and t lies in between 0 to 1, then since y belongs to 0 to 1 minus x, so y, and this is t, this is 0, this is 0, 1 minus x 1, so t lies in between 0 to 1, and t1 is 1 minus x times dt. So put all these informations here. So you get x equals to 0 to 1, t equals to 0 to 1, x power L1 minus 1. Now put the value of y, so that will be 1 minus x whole power L2 minus 1, t to the power L2 minus 1, 1 minus x minus 1 minus x times t whole power L3 dx obviously will be there, but for corresponding to dy, another term will be there. Yes, so this part. Yeah. So corresponding to dy, there will be one more term, and that is actually 1 minus x dx dt, and I have already written 1 by L3. So now if you simplify all the terms, then it going to turns out to be x equals to 0 to 1, t equals to 0 to 1, x power L1 minus 1. So let us combining all the terms, 1 minus x whole power L2 minus 1, t power L2 minus 1. There, if you take 1 minus x common, then it is going to be 1 minus x, 1 minus t whole power 3. So individually power will be raised, and that is one more term, 1 minus x dx dt. This is the full all the terms. So now let us separate the terms x and y. Okay, so it will turns out to be x equals to 0 to 1, x power L1 minus 1, 1 minus x, here is L2 minus 1, here is 1 more, so L2 plus L3 minus 1, and yeah, so I think 1 minus 1 also cancel out because there is 1 minus x more. So this will be dx times t comes to 0 to 1 t power L2 minus 1 1 minus L3 dt, right? Now you know what is this is. This is actually beta function. So this is actually beta of L1 L2 plus L3 plus 1 times beta of L2 and L3 plus 1 and divided by L3, this L3, right? Now you just put to the beta m equals to beta m gamma n by gamma n plus n. So if you put the values, then you will get gamma L1 gamma of L2 plus L3 plus 1 by gamma of L2 plus L3 plus L1 plus 1, and then we will do two terms, gamma 2 gamma L3 plus 1 divided by gamma of n plus n, and 1 by L3 will be there, right? Now you say gamma L1 gamma L2 and gamma n plus 1 is gamma n. So from here it will be gamma L1 gamma L2, this one, and gamma L3, the gamma n plus 1 equals to n gamma n, right? So what is n? That will be actually L3 n gamma n. This is n gamma n, right? And keep this one as it is, L1 plus L2 plus 1, and this term you separate this term gamma, this treat this L2 plus L3 as n, then we will get okay. Yeah, so gamma of L2 plus L3 plus 1, gamma of L2 plus L3 plus cancel out, and this L3 will be cancelled out, and you get your resultant from this. This is what you had to prove. Yeah, so by this formula, the benefit of this formula is that you don't need to even use the polar form. You can easily compute double integral in just one line if you can remember this formula, right? So now as a simple corollary, in case of three variable, yeah, so I have written the thing that when the integral is extended to all positive values of the variables subject to the condition, so this is positive means all xi's are positive and they satisfies this. So individually they are less than or equals to h and they are positive. Then x1 whole power L1 minus 1, x2 whole power L2 minus 1, x3 whole power L3 minus 1, dx1, dx2, dx3 is equal to x power L1 plus L2 plus L3 times gamma L1, gamma L2, gamma L3 divided by gamma of 1 plus L1 plus L2 plus L3. So you know the result for when h equals to 1. So to get in your already proved form, so the simple substitute we have to use, that is x1 equals to h charge times ui, and that is for I equals to 1 to 3. I equals to 1 2 3. Yeah, so then Now if you use d of xi equals to h times a ui, and that is true for all three values, right? So now think that you put all these things in the given information in the given equation. So put all the information in the above integration. We get what you get, that triple integration you put h power u1 minus 1 u1 l1 minus 1, and for x2 then again get u power l2 minus 1, again h power l3 minus 1, and this is u3 whole power l3 minus 1, right? And then dx1 dx2 dx3, so 3h will be there, h cube du1 du2 du3. Now here if you simplify just this l2 plus l3, because minus 1 minus 1 minus 3, and here there is another power, this will cancel out, and this turns out to be u1 l1 minus 1 u2 l2 minus 1 u3 l3 minus 1 du1 du2 du3, right? And now you have here all the ui's now varies from 0 to 1, right? Here let me write shortly that xi ui, when xi is 0 ui is also 0, when xi is 8 this is 1, so it varies from 0 to 1, right? Then by Dirichlet formula it is actually gamma of L1 gamma of L2 times divided by gamma of L1 plus L2 plus 1 by Dirichlet formula. This is by theorem, right? So now if you have any doubts so far, then please ask, otherwise I shall move to the next thing, that is the Liouville extension theorem for this thing. So yeah, so do you have any doubts, then please ask, otherwise I shall now do Liouville theorem, extension theorem for the Dirichlet, right? Hence the corollary, right? Yeah, so now Liouville's extension of Dirichlet theorem says that if I have volume integration in three variables, say x, y, z, and such that the range of the variables varying in this way, that it found that it varies from h1 to x1 plus x2 plus x3. Earlier it was positive and was bounded by constant, that we have just seen in the last corollary, but here you have also a lower bound and upper bound, right? So in some sense you have to calculate from 0 to h2 and then 0 to h1, right? So I mean you have to somehow this one and 0 to h1 and subtract, but that is actually nothing but h1 to h2 integration. Yeah, so yeah, so the exact statement, that this is a rough idea, and what should be pH. To the exact statement is given by the triple integration x power 1 whole power L1 minus 1, x2 whole power L2 minus 1, x3 whole power L3 minus 1, and f is an arbitrary function. F evaluated at x1 plus x2 plus x3. Tx1, Tx2, Tx3 is actually equals to this fraction value, where the numerator part is product of the gamma li's and the denominator is gamma of sum of the li's, right? And f is a function, scalar field that is defined in the domain where we have taken integration, and since this is a scalar value, so we can evaluate from h1 to h2 f of h and h power L1 plus L2 plus L3 minus 1 dh. This is the formula, right? So where let me write also where f is a real valued integrable function on, right? Yeah, so let's start. So as usual, if you have any doubt, then don't hesitate to ask. Yeah, so by Dirichlet theorem, by Dirichlet theorem, if x plus y plus z is strictly less than 1, then we have just seen I equals to triple integration x power L minus 1, y power m minus 1, z power L minus 1, dx dy dz equals to gamma L gamma m gamma n by L plus m plus n, sorry, plus 1, right? You have just seen, right? And h power n plus n plus n, right? Now similarly, if x plus y plus z less than or equals to h plus delta h, then I equals to x power L minus 1, y power m minus 1, z power then minus 1, dx dy dz, that is actually gamma L gamma n gamma n divided by gamma of n plus L times h plus delta h whole power L plus m plus n, right? So write this one as 1 and this one as 2. So now in order to get integration, so you just subtract them. Now from 1 and 2, from 1 and 2, we conclude that the value I extended to all positive values, because now I want to quantity so that both of 1 and 2 hold, so I have to take values either the edge lies both in case of 1 and 2, extended to all such positive values of the variable such that their sum lies such that, yeah, I need this because I want to use both 1 and 2, such that their sum lies in between h and h plus delta h, right? Then in such case I turns out to be gamma L, gamma M, gamma N by gamma of L plus M plus N plus 1 equals to times H plus delta H whole power L plus M plus N minus H power M plus M plus N, right? Same thing. So now for first order approximation, for the first order approximation, x plus delta x whole power n is nothing but, that is what, f of d minus f of a equals to, by Lagrange theorem, n times derivative of the x power n function, right? Then I turns out to be gamma L, gamma N by gamma L plus M plus N times L plus M plus N plus N times H power L plus M plus N minus 1 delta H, right? But yeah, so but what is gamma of L plus M plus N plus 1? So gamma N plus 1 is nothing but n gamma N, right? So the rest of the term will be cancel out and it will be L plus M plus N minus 1, sorry, delta H, right? So now when H1 less than x plus y plus z less than H2, the value of the above integration turns out to be times H1 to H2 f of H power L plus M plus N minus 1 pH. right? So yeah, so if you have any doubt so far, you just ask. Now we shall try to solve some problems based on these things, so that we can you can understand the theorems much better way. Yeah. So yeah. So I think I have written all the things almost, but don't worry. As usual, I always provide the full handwritten solution, so you not no need to, you just understand the steps here, what is going in between, right? Yeah. So now we shall see some problems using this Liouville theorem and Dirichlet formula for the volume integration, right? Yeah. So, now the problem says you need to find x power n minus 1, y power n minus 1, z power n minus 1, dx, dy, dz, where the variables x, y, z are all positive and satisfy this condition. But since we know Dirichlet formula for x plus y plus z less than or equals to conditions like this, for condition like this one, right? So in order to convert this condition, we need to substitute some cleverly. So substitute, I want to make it u plus b plus w less than or equals to 1. So substitute, right, x by a whole power p to be u, y by p whole power p to be a, and z by c whole power r to the w. Just wait, turn on the fan, it is too hot. Right, then this implies x equals to, since x or y z all are positive, so this is going to be a power u by 1 by p, y equals to b times e power 1 by q, and z equals to c times w by 1 power p. And then dx equals to a 1 by p u or 1 by p minus 1 du, dy equals to b 1 by q e power 1 by q minus 1 dt, and dz equals to c 1 by r dw, right? So now you substitute all this in the given integration, right? Then we get, if you put all the values, then what will you get? Triple integration x power l minus 1, y power n minus 1, z power n minus 1 dx dy dz x equals to a 1 power l minus 1 u 1 power t by l x so x power l minus 1 a power l minus 1 u power l minus 1 by t. Similarly b power l minus 1 v power n minus 1 by q and c power n minus 1 w power n minus 1 r. Now put the values of dx. So dx is a by p e power 1 by t minus 1 d by q e power 1 by q c by r w power 1 by r minus 1 du dv dw, right? And however if you select since here a power l minus 1 and a power a, so a power l will be there, a power l, b power m, c power n. Similarly, because one power will be cancelled out by here and the quotient pqr will come out, right? And in the inside u power l by p minus 1 by p plus 1 by p minus 1. So ultimately you are getting l by p minus 1 v power by m by q minus 1 and w power n power minus r du dp dw, right? And now by Dirichlet's theorem, so can someone confirm what is going to be the final answer? At least this step, that is gamma of l by t, gamma of m by q, gamma of n by r divided by gamma of 1 by n by q n by q n by r, right? And that is the actually final answer. Yeah, so any doubts so far? If you have, then you just ask, otherwise I have to move to the next one. Yeah, so let me write one small corollary regarding this thing. So yeah, let me write sketch corollary. Corollary, it says triple integration x power n minus y n minus 1 whole power z minus 1 dx dy dz actually equals to a power n e power n c power n by gamma n gamma n gamma n by sorry equals to, let me first write, then you will understand. Gamma of L by 2, gamma of M by 2, gamma of N by 2, N plus N by 2, where this is the main thing, where the multiple integral the multiple integral is taken through the part through the part of the ellipsoid x square by a square plus y square by b square plus z square by c square equals to 1, which lies in the positive of them. Which lies in the positive of them. This is one particular case because then because so let me write the proof also or solutions also. Nothing but P equals to P equals to R equals to 2 in question 1, and you will get the answer to this in question 1, right? Yeah, so if you have any doubt so far, then please ask, otherwise I will next book. Yeah, so earlier there was no integrand, now there is integrand. Integrand is actually the function x, y, z. Now you have to find the triple integration x, y, z, x by a whole square, y by b whole square plus z by c whole square less than or equals to 1. Right, so as you can obviously go for the polar decomposition, but see by using this formula, Dirichlet formula, how easily you can solve this. So let me write remark. You can obviously solve by polar coordinates. But the Dirichlet's theorem and the Liouville's extension theorem help to find or evaluate the value very quickly and less complication. Right? Okay, so we shall now use the polar coordinates. Yeah. So for that, as usual, you have to make somehow this make this as u plus v plus w less than or equals to 1. So put x by a whole square equals to u, y by b whole square equals to b, and z by c whole square equals to w. then this implies x equals to a e power half, y equals to a e power half, z equals to c w power half. The given integration becomes, right, so put x equals to a e power half, y is a e power half, w is c w power half, and dx equals to a half u power half minus 1 e half e minus 1 c half w minus 1 whole times du dv dw, right? du dv dw. That is actually equals to, so a square c square by 8 gamma 1 by gamma 4 times, yes, that is actually equals to a square b square c square by huge gamma n plus 1 equals to gamma n, gamma n. And what is this? The integration integral. Okay, this is recall that Dirichlet formula is valid only for positive values of the variables. Dirichlet's theorem valid only for positive values of the variables. Yeah, so the integration given integration in the first option, the given integration in the given integration in the positive octane the given integration in the positive octane the given integration in the positive octane is equals to this. Since there are 8 coordinate quadrants in 3D, since there are 8 octanes and all are symmetric in the all all are symmetric in the sense there are 8 octants and all are symmetric and all are symmetric in the ellipsoid. We have the total we have the I equals to xyz dxy dz equals to 8 into a square b square by 48 equals to a square b square c square by 6. Right? So now I quickly move to the question 3. If you do not have any doubts, then ask. Otherwise, I shall move to the next. Yeah, so it says we need to find the triple integration x y z sin x plus y plus z dx dy dz for all positive values of the variables x y z with this condition. Yeah, so it is just nothing, just you have to put this thing in extension formula. So for that, so I equals to integration x power 2 minus 1 y power 2 minus 1 z power 2 minus 1 and the sine of, let me here write it so that you become more convenient to this is dy dz right, where f of x equals to t equals to sine of t, right? And now this is actually equals to gamma 2 gamma 2 gamma 2 by gamma 6 times 0 to pi by 2, because this is now really equals to h to sine of 8 h power 2 plus l plus m plus n minus 1 times dh, and by which theorem? By Dirichlet theorem. Right? And now this is actually equals to 1 by gamma 6 times 0 to pi by 2 h power 5 sin h dh, and that is actually equals to, so now if you integrate by parts, then it will turns out to be 120 5 into pi by 4 16 minus 15 pi square plus 120. So let me write here integration h power 5 sin h is integration by parts, that is actually equals to h power 5 sin h integration. First function remains derivative and second function integration. Yeah, so cos of h minus 5 h power 4 minus of sin h plus 20 h cube minus cos h plus 16h square minus sin h plus minus plus, this will be negative, sorry, and again this is x 128 times cos h minus 120 sin h. Now you put the values 0 and pi by 2, you will get this. So 0 and pi by 2. Right? Yeah, so if you have any doubts, please raise hand, otherwise I shall move to the next problem. Right, so let's move to the next problem. Yeah. So now the question says that find the integral of this dx1, dx2 dot dxn, and the integrand is square root of x square minus xn square plus x2 square. Sorry, there. Yeah. So x square minus x1 square plus x2 square dot xn square, and the integral is extended to all positive values of the variables, that is x1, x2, xn, such that this expression is positive. So variables means that is xi, and this is real. So in order to be this real, a square minus, so let me write, yeah, so in order to get the real expression, we have to take x square minus, okay, sorry, this is x1 square, x1 square, x2 square plus dot xn square is greater equals to 0. This implies right. So this is the thing that I had, and all xi greater equals to 0, that is also given. So now you have to somehow convert this integration to integration where the expression can be written as u1 plus u2 plus c3 to u3 dot un, so that their sum is less than or equals to some constant, right? So for that put okay, so put xi square equals to a ui, and this is for every n, right? Therefore this implies xi dxi is actually equals to a square dui, right? Thus the integral becomes the thus the integral becomes integration, that is actually n variable case that I am going to use. That is actually, it is given ax to dot 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 axn by a square minus x1 square plus x2 square xn square, right? Okay, so now I shall put all the informations here. So if you put, then you will get half 1 by 2 power n integration, because every dxi will be divided by 2 and there are n many variables, so it will be 1 by 2 power n, and dxi is a square. Okay, so if you now put the value of dxi, the variable powers will be u1 whole power half minus 1, u2 half whole power minus 1, dot 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 u n half minus 1, and there it will be du1 du2. Whatever I am doing, I am only doing for to convert this integration to a integration where I can use the Dirichlet's formula. Right? In my experience, this is the one of the easiest formula to compute the multivariable, in fact volume integrations. You can just add the clearance, you can solve it. Yeah, so now where okay, sorry, let me, there was, I think I have done one mistake. So as my calculation, there's which no a input there. That is why there no power of a has come here. Or you can take, then you can the calculation will be much difficult. Where u1 plus un is less than or equals to a square. Okay, so just wait a minute, because as you know that I earlier I declared that my laptop cannot proceed 2 hours recording at a time. So I shall stop the recording and then again I shall stop. Then again I shall start. So let me save this 1 hour recording.